Just like perimeter problems on the ACT, area problems are often asked in obscure ways. So in this video, I want to review a few different types of problems regarding area. A triangle is graphed in the standard coordinate plane. It has vertices at -2, 2, -2, -1, and 1, -1. What fraction of the triangle's total area can be found in quadrant 3? Let's start by graphing this triangle. So we have -2, 2, -2, -1, and 1, -1. And that is going to form our triangle. And we want to know how much of the total area is in quadrant 3. Quadrant 3 is the bottom left quadrant. So let's first get the total area of the triangle. The total area of any triangle can be found with the formula 1/2 base times height. And looking at the graph, we can see that the base is 3 units, and the height is also 3 units. So the total area is 1/2 times 3 times 3, or 4.5. Now we want to know what fraction of the triangle's total area is found in quadrant 3. So we're looking at this area right here, which appears to be 2 square units. So we're looking at 2 out of 4.5. And if we write that as a simplified fraction, we're looking at 4/9. Find the area of the trapezoid graphed below. Alright, it looks like we're given 4 vertices, labeled A, B, C, and D. So all we need to do, if we remember the area of a trapezoid formula, it is base 1 plus base 2 over 2 times the height. So it looks like base 1 is 2 units, so 1, 2 units, and base 2 is 1, 2, 3, 4, 5, 6 units. So we're looking at 2 plus 6 over 2, which is 4, and then the height. And we're looking at the height here, so we have 1, 2, 3 units for the height. So times 3. So that is going to give us 12 square units. Pictured below is a rectangle that contains 3 circles, each of radius 1. Approximately what percent of the total space of the rectangle is taken up by the circles? So first, let's get the area of the rectangle. That is equal to the length times the width, so 6 times 10, or 60. And then we have the area of each circle, and that's going to be pi r squared, or pi times 1 squared, which is just equal to pi. So now we have 3 circles, so that is 3 pi for the area of the circles over the total area of 60, and then times 100%, which is 15.7%. A square piece of white paper with an area of 25 square inches is exactly centered over a square piece of blue paper. The distance from one of the sides of the white paper to the matching side of the blue paper is 1 inch. So let's draw that in. So we have this, which is 1 inch. What is the area of the part of the blue paper that is exposed? Alright, so it looks like we have the length of one of the sides of the white paper must be 5. because the total area of that white square is 25. And since it's a square, we can take the square root of that, which is 5, to get the length of one of the sides. Because this paper is exactly centered over the blue paper, we can figure out the total length of the sides of the blue paper. So we'll take that 5 and we're going to add the 1 inch, and then we're going to add the 1 inch on the other side. So now we know that the length of one of the sides must be 7. So now we just need to subtract the area of the blue paper and the area of the white paper to get the area of the exposed part of the blue paper. So we have 7 squared minus 5 squared is equal to our area of the exposed blue. And 49 minus 25 is 24, so 24 square inches.